Hello, welcome back to my channel. This is Nipa Patel from the Math Masters, and today we are going to cover all the remaining questions of Chapter 1 Relations and Functions Exercise 1.1. Please like the video and subscribe to get the notifications for the new and upcoming videos. Let's start.
Question 12. Show that the relation R defined in the set A of all triangles as R equals T1, T2, where T1 is similar to T2, is equivalence relation. Consider three right triangles, T1 with sides 3, 4, 5, T2 with sides 5, 12, 13, and T3 with sides 6, 8, 10. Which triangles among T1, T2, and T3 are related? So first we are going to work on this, that we need to show that this is equivalence relation. Okay, what are you given in that relation? That R equals T1 comma T2, where T1 is similar to T2. So let me rewrite that. R is equal to T1 comma T2 such a way that T1 is similar to T2. Now, since we need to show that this is an equivalence relation, we need to show that this relation is reflexive, this relation is symmetric, and this relation is transitive. Since it's going to be all three, we will be able to conclude that it's going to be an equivalence relation. So for now, let's start with reflexive. Now, definition of being a reflexive relation is what? That you must have A comma A belongs to R for every A belongs to A. So for this, let T1 comma T1 belongs to R. So if T1 comma T1 belongs to R, that means from this T1 is similar to T2, we can, in this case, T1 comma T1. So we can say T1 is similar to T1. Of course it is similar to T1 because it is congruent to T1. We are talking about the same triangle. So it must be similar to itself. So T1 is similar to T1 and it is true. So it is true. That means T1 comma T1 belongs to R, and that means A comma A belongs to R. That's what we were supposed to show to make it a reflexive relation. So it is a reflexive relation. So R is reflexive. Okay, so R is reflexive relation. Now we are going to check for symmetric. Now definition of symmetric relation is what? That if you have A comma B belongs to R, then you must have B comma A belongs to R. Okay, so let T1 comma T2 belongs to R. So if T1 comma T2 belongs to R means what? T1 is similar to T2. Now if T1 is similar to T2, can I say that T2 is similar to T1? Of course, same thing, right? And if T2 is similar to T1, we can say that T2 comma T1 belongs to R. And since T2 comma T1 belongs to R, we can say B comma A belongs to R because that's what we took. A equals T1, B equals T2. And since we have B, A belongs to R, that means it is a symmetric relation. So R is symmetric. Now we are going to show transitive. Okay. Now definition for transitive is what? That if you have A comma B belongs to R and you have B comma C belongs to R, you must have A comma C belongs to R. So for this, let T1 comma T2 belongs to R and T2 comma T3 belongs to R. Now since T1 and T2 belongs to R means what? That T1 is similar to T2. And since T2 comma T3 belongs to R, that means we can say T2 is similar to T3. And from these two facts, that T1 is similar to T2 and T2 is similar to T3, we can say that T1 is similar to T3. Why? Because T1 was similar to T2, but T2 was similar to T3. So of course the triangle T1 is similar to the triangle T3. And that means T1 comma T3 belongs to R. And since T1 was A and T3 was C, that means AC belongs to R. And as soon as we prove that AC belongs to R, that means R is transitive. So R is transitive. And hence you can say that hence R is an equivalence relation. Now we were given something else as well in the question, that consider that, okay, so let me do that part here so we can see those dimensions. Okay, now so for this part, consider three right triangles. So we are given three right triangles. Let's say that T1 we are given with 3, 4, 5. T2 we are given as 5, 12 and 13, and T3 we are given as 6, 8 and 10. And we are supposed to find that which triangles among T1, T2, T3 are related. That means which triangles are similar to each other, right? So we just need to look at the ratios of these sides, right? Now if we look between T1 and T2, what we are going to get, 3 over 5 equals 4 over 12 equals 5 over 13, which is not true. They are not same. So T1, T2 not related. T1 and T2 not related. Let's check for T2 and T3. So that means T2 and T3. So these two. So 5 over 6 equals 12 over 8 equals 13 over 10. Again, not true. So these are again not related. So T1 is not related to T2. T2 is not related to T3. We can still check one more, which is T1 and T3. So let's check for T1 and T3. That means first and last. So 3 over 6 is equal to 4 over 8 is equal to 5 over 10. So 3 over 6 is half, 4 over 8 is half, 5 over 10 is half. So yeah, this is true. So that means T1 is related to T3. Which triangle among T1, T2 and T3 are related? So T1 is related to T3. This is your answer to that. Question 13. Show that the relation R defined in the set A of all polygons as R equals P1, P2 such that P1 and P2 have same number of sides is an equivalence relation. What is the set of all elements in A related to the right triangle T with sides 3, 4 and 5? So we got actually two questions in here. So first we are going to do till here, that we need to prove that this given relation is an equivalence relation. So to prove that it is an equivalence relation, we just need to prove that it is reflexive, it is symmetric and it is transitive. And when a relation is all those three, then it is an equivalence relation. So let's just first write that relation R is equal to, we are given P1 comma P2 such that P1 and P2 have same number of sides. Same number of sides. Okay, now P means what? Polygon. So we are given polygons and such a way that relation builds up that P1 and P2 have same number of sides. Okay, now let's start with reflexive. Now definition of reflexive says what? That if you have A comma A belongs to R, then it must be for every A belongs to R. Or let me rephrase it, that reflexive relation means you must have A comma A belongs to R for every A belongs to A. Now for this case, let P1 comma P1 belongs to R. I am taking for A P1. So if A comma A is in R, that means P1 comma P1 must be in R. And if P1 comma P1 in R, then what condition from this given relation that we are given that if you have P1 comma P2, then P1 and P2 have same number of sides. Here we got P1 and P1. So that means P1 and P1 have same number of sides. Does this make sense? Is it true? Like, let's think for a bit. We got a polygon and we are comparing the number of sides of that polygon with that polygon only. So of course that polygon, we got one polygon, and if we count the number of sides in that polygon, that must be same as the sides of that polygon. We are talking about the same polygon. So of course P1 and P1 have same number of sides. And since this is true, which is true, that means P1 comma P1, yes, it belongs to R. And that means since our P1 was A, that means A comma A belongs to R. As soon as we prove that A comma A belongs to R, that means we can say that R is reflexive. Now we are going to start talking about symmetric. Now definition of symmetric says what? That if you have A comma B belongs to R, then you must have B comma A belongs to R. So for this, let P1 comma P2 belongs to R. Now if P1 comma P2 belongs to R, that implies what? This same thing. P1 and P2 have same number of sides. So that means P1 and P2 have same number of sides. But the same thing I can write this way as well, that P2 and P1 have same number of sides. This is still the same thing, right? Because P1 and P2 have same number of sides, or you can say other way around, that P2 and P1 have same number of sides. It's the same truth, right? So that means P2 comma P1, that belongs to R. That means B comma A belongs to R, because our P2 was B, P1 was A. And as soon as we have B comma A belongs to R for our AB belongs to R, that means your R is symmetric. So R is symmetric. Now we are going to start working on transitive. Now definition of transitive is what? That if you got AB belongs to R and you got BC belongs to R, you must have AC belongs to R. So for this case, let P1 comma P2 belongs to R and P2 comma P3 belongs to R. Now if P1 comma P2 belongs to R, means what condition? P1 and P2 have same number of sides. So this implies that P1 and P2 have same number of sides. And if P2 comma P3 belongs to R, that implies that P2 and P3 have same number of sides. Now if you have P1 and P2 with same number of sides, and if P2 and P3 has same number of sides, then of course you can say that P1 and P3 has same number of sides, right? And since P1 and P3 has same number of sides, you can say that P1 comma P3 belongs to R. And since our P1 was A, P3 was C, that means AC belongs to R. And since AC belongs to R, we can say R is transitive. So R is all three. R is reflexive, R is symmetric, and R is transitive. Hence, R is an equivalence relation. Now we had some other question as well. So we had to prove that it is an equivalence relation, which we just did. Then what is the set of all elements in A related to the right angle triangle T with sides 3, 4 and 5? So that is going to be, so let me write here. So that's going to be what? Then let me draw that triangle. So if this is 3, if this is 4, if this is 5 and this is a right triangle, then the set of all triangles in a plane is going to be similar to this then, right? Because this triangle, how many sides this triangle has? It's a triangle, of course, 3, right? 3 number of sides or number of sides equals 3. Number of sides equals 3. We were talking about number of side in that polygon for that other half of the question. So when we are given this triangle, they were also talking about that same relation. So in this triangle, if you count, then you got 3 sides. It's a triangle, of course you are going to have 3 sides. So the set of all the elements in A is going to be what? All the triangles, right? So answer is what? The set of all triangles in a plane or any triangle that you can think of. Every triangle in a plane is going to be related to this triangle. Why? Because they will have same number of sides. Because any triangle, even though it's a right triangle, it's an equilateral triangle, it's a scalene triangle, it's an isosceles triangle, any triangle, acute, obtuse, every triangle will have just number of sides equals 3. So of course those all triangles in that plane is going to be related to this triangle. Question 14. Let L be the set of all lines in xy plane and R be the relation in L defined as R equals L1 comma L2, well, where L1 is parallel to L2. Show that R is an equivalence relation and then find the set of all lines related to the line y equals 2x plus 4. So first we are going to prove that this is an equivalence relation. Which one? This given R. Okay, so let's write down that R, you are given L1 comma L2 such that L1 is parallel to L2. And since we need to show that it is an equivalence relation, we need to show that it is reflexive, it is symmetric and it is transitive. So let's start with reflexive. Now to show that it is reflexive, the definition. The definition is what? That A comma A belongs to R for every A belongs to A. So in this case we are going to say that let L1 comma L1 belongs to R, and that means what? That L1 is parallel to L1. Yeah, of course. If we are talking about the same line, then yeah, of course that line is parallel to itself. So yes, it is true, which is true. That means L1 comma L1 belongs to R, and since L1 is nothing but our A, that means A comma A belongs to R, which we were supposed to prove, and that's what we just did. So R is reflexive. Now we are going to show symmetric. Now the definition of symmetric relation is what? That if you have A comma B belongs to R, that means you must have B comma A belongs to R. So for this, let L1 comma L2 belongs to R. Now if L1 comma L2 belongs to R, that means L1 is parallel to L2. Now if L1 is parallel to L2, can't I say that L2 is parallel to L1? Of course, right? Same thing. If one line is parallel to the other, that means that other line is parallel to that first one, of course. So we can say L2 is parallel to L1, and that means L2 comma L1 belongs to R, and that means B comma A belongs to R. So R is symmetric as well. Okay, why? Because our L2 was B, L1 was A, so B comma A belongs to R. And as soon as we prove for AB belongs to R that B comma A also belongs to R, that means it is symmetric relation. Now we are going to start working on transitive. So the definition for transitive is what? That if you have A comma B belongs to R and B comma C belongs to R, you must have A comma C belongs to R. So for this case, let L1 comma L2 belongs to R and L2 comma L3 belongs to R. Now if L1 and L2 belongs to R, that means what? That L1 is parallel to L2, because that's what we are given, right? See, L1, L2 such a way that L1 is parallel to L2. So if L1, L2 is in R, that means L1 is parallel to L2. And if L2 and L3 is in R, that means L2 is parallel to L3. Now if L1 is parallel to L2 and L2 is parallel to L3, we can say L1 is parallel to L3. And since L1 is parallel to L3, we can say L1 comma L3 belongs to R. And that means AC belongs to R, because our L1 is A, L3 is C. And since we just proved that AC also belongs to R for AB and BC belonging to R, so that means R is transitive. So R is transitive. Now, since it is, see, R is reflexive, R is symmetric, R is transitive, so we can say hence R is an equivalence relation. Why? Because it was all three, right? Now I think we got some other question as well, which is show that R is an equivalence relation and find the set of all lines related to the line y equals 2x plus 4. So if I try to draw that line in here, y equals 2x plus 4, so it is passing through the y-intercept 4 and the slope is 2. So this is actually that line. Which line? 2x plus 4 line. Y equals 2x plus 4 line. So we need to write all the possible sides, all the possible lines which are parallel to this line. So any line which is this way, or any line which is this way, or any line maybe somewhere here, or any line somewhere here. So what is the difference in all these lines? They all have same slope. Of course. Why? Because they are parallel to each other. So if they have same slope, and in this equation y equals 2x plus 4, this 2 shows the slope. That means if every line has same slope, then every line has 2x in it. But every line's y-intercept is different. Look at here. If I extend this, then this is the y-intercept. Here, this is the y-intercept. Here, this is the y-intercept. Here, this is the y-intercept. If I extend again this y, x is, then this is the intercept here. So everywhere slope is same, just the y-intercepts are different. So that means the set of those lines. So I can write here that the set of all lines related to the line y equals 2x plus 4 are y equals 2x, and then see, I am going to write just k. K can be any number, where k can be any number. So y equals 2x plus k. Plug in any number for k and that's going to be parallel to this y equals 2x plus 4. Okay, we can say k is any number. K belongs to, let's say, r. K is any real number. So y equals 2x plus k. All these lines are going to be parallel to this y equals 2x plus 4. Question 15 is a multiple choice question. You are given that let R be the relation in the set 1, 2, 3, 4 given by R equals 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2, and we need to choose correct answer that what this relation is going to be. So let that A is equal to 1, 2, 3, 4 and our R is 1, 2, 2, 2, 1, 1, then 4, 4, then 1, 3, then 3, 3, and 3, 2. This is our R. Now 1, 2, 3, 4. We got 4 elements in that A. So we must have 1, 1, 2, 2, then 3, 3, and then 4, 4 to be reflexive, which we got. See, we have 1 in here, so 1, 1 we got 2 in here, so we must have 2, 2, we got it here. Then 3, we must have 3, 3, 4 is here, so we must have 4, 4. We got all this 4, so it looks like it is reflexive. Okay, so it is reflexive. Now let's check for symmetric. Is that symmetric? Okay, you got 1, 2, so do you have 2, 1? Okay, we don't have 2, 1, so it is not symmetric. And as soon as we get it is not symmetric or not any one of those, that means it is not a equivalence relation, right? So it is not D, then it is not symmetric. So R is symmetric, no. Then R is reflexive, so yeah, R was reflexive, and symmetric but not transitive. Okay, so let's check for transitive and then we can be sure that it's going to be what option. So for transitive, you got 1, 2, you got 2, 1, so 1, 2, okay, you have that. Then you got 1, 1, you got 1, 3, do you have 1, 3? Oh, we don't have 1, 3, see? Or do we? Hmm. We got 1, 1, we got 1, 3, so we must have, oh yeah, this is 1, 3, of course, right? Okay, so we got 1, 3, then this is 2, 2, okay, 3, 2 and 2, 2. So we must have 3, 2, which is already okay. Yeah, so it is transitive. Looks like it is transitive. So whichever option in this A and B says it is reflexive, it is transitive. It is reflexive and transitive but not symmetric because it was not symmetric. So yeah, this is our answer. Option B is the correct answer. Question 16. Let R be the relation in the set N given by R equals A comma B, where A is equal to B minus 2 and B must be greater than 6. Choose the correct answer. So first we got 2 comma 4 belongs to R. Now let's check whether that belongs to R or not. So if 2 comma 4 belongs to R, that means A equals 2 and B equals 4. And is this correct that A equals B minus 2? Okay, so for now, yeah, A is equal to B minus 2. And the other condition was what? That B must be greater than 6. But 4 is not greater than 6. So A is not our answer. So let's cancel that out. Now we got 3 comma 8 belongs to R. That means A is 3 and B is 8. A must be equal to B minus 2. So 8 minus 2, we won't have 3. So B is not the answer. Now check for C. 6, 8. So let's make A equals 6, B equals 8. Now our A, see, we are given A equals B minus 2. So that means in this case B is 8. So 8 minus 2. And our A is also 6. So yeah, this checks out. And your B must be greater than 6. In this case, your B is 8. So yeah, 8 is greater than 6. So this checks out easily. Looks like this is our correct answer. Just to be safe, let's check this D as well. So that means this is our A, this is our B. And we are given what this condition that A is equal to B minus 2. Now B is 7. 7 minus 2. You are going to get 5 and A must be 8. So D is not the correct answer. So for this, your answer is C.
Okay, so that's it for today. Please remember to like and subscribe the video. See you all in the next video. Thank you.